Hello everyone, my name is Walter Goody. I'm an applications engineer here at Mentor Graphics, and welcome to today's webinar, ModelSim GUI Essentials. So obviously GUI stands for Graphical User Interface, and we're going to talk about some features of ModelSim that you may not be familiar with. ModelSim has a lot of tools, and what we find is that a lot of people use the tool the way they know how, and that there may be a bunch of debug tools and a bunch of features of the tool that you just haven't learned, and because you don't know it, you don't use it. So the intention of this webinar is to kind of introduce you to more of the features in the graphical user interface, and to try to get you to get the most productivity out of your time spent simulating. So first of all, ModelSim has a lot of great tools, and there's a lot of them that people probably don't know about. In this workshop, we're going to try to show you how to be more effective with the GUI. This workshop can be used as a toolbox of techniques for common debug and simulation tasks. So the first thing we'll talk about is just the ModelSim shortcut on your Windows desktop. So most people are using it in a Windows environment, and one of the things we've noted that I always used to get annoyed with is every time I started ModelSim, I had to go change directory to my project directory. So one of the things that I've started to do is I create the shortcut on my desktop, and then I right-click on it, and I do the properties, and once I do that, then I can come in and I can use maybe I can modify this and say, okay, when you launch ModelSim, automatically run this startup script. So that's one option. Probably the main one is the start in location. So by default, the tool will start in the installation directory /examples, and then we have to go and change directories to where our project is. So I'll create one of these shortcuts for every project I'm working on, and then I'll change the start in directory. I'll go find that in a Windows window, and I'll copy paste that over to here so that now every time I click on that shortcut, it automatically starts up in my project directory. Second thing we'll talk about is getting help on the tools. So the first thing everyone does is they're asking questions. How do I get help? Well, if you go to the help menu on the main taskbar at the top here, you go to help, and you can bring up either the PDF bookcase, which is a set of PDF manuals, or you can bring up the HTML browser Info Hub. If you bring up the Info Hub, that gives you this search box, and you can search on topics, keywords, whatever, and it will search through all the documentation and give you topics. It also gives you access to all of these different manuals. So the main manuals you're going to want to look at is the ModelSim User Manual. That is a more how to do certain tasks in the tool. So I want to use the waveform window. You come in and you look in the user manual to figure out how to do that. The GUI reference manual covers more or less the same kind of topics that we're going to be covering today. How to use the GUI to its greatest effect. The command reference is a list of every command that you can issue in the transcript window, or that you can put into scripts, and what all the different things do. And then finally, the ModelSim tutorial guide. So the tutorial guide is great because it gives you a bunch of lessons on how to do tasks like graphical debug, code coverage, etc. And it points you to the data directory where some labs and things are ready. So that's kind of the main things in the Info Hub. Now let's look at a kind of general overview of the ModelSim GUI. So the ModelSim GUI has a lot of tools for different tasks. Each tool operates maybe in more than one Windows. The GUI is very configurable. There are some defaults that we can set up, and then you can customize the GUI to look any way you want. So windows can be placed alone, or they can be placed within a tab group. And so this is kind of the cockpit that I'm sure most of you already are familiar with. But you'll see this is kind of a framework that different windows can be plugged onto, and we can move them around. So for instance, right here we have a couple of windows that are tabbed together. We have the library tab and the sim tab. We can select different tabs and bring up different windows. Any one of these windows, you'll see, has this bar. And if we select this kind of bumpy handle right here, we can drag that window over and place it in the middle of another window, and then that will group those two together and make them part of the same tab group. Over here is the maximize this window within the framework, pop that window off the framework, or close that window in the framework. One of the things you'll see in ModelSim is that there's a lot of icons, and they have shapes in different colors. So anytime you see light blue in the icons, you know that that is referring to either Verilog or System Verilog code. If it's dark blue, it is VHDL code. If it is green, it's System C code. If it's magenta, it's PSL. And then, for instance, squares, like this blue square, is a VHDL entity architecture pair. This light blue square is a Verilog module. These circles are processes or always blocks or whatever within the code. So these dark blue circles are VHDL processes. The light blue circle is a Verilog always block. Over in the wave window, if they are diamonds, they are going to be signals of some kind. A diamond with an arrow, so that's an out arrow, so that's an output port. Or excuse me, that's an in arrow, that's an input port. This is an output port. So the arrows indicate port direction. And then for assertions and cover directives, triangles that are in the wave window are referred to assertions, and chevrons, or Star Trek symbols, as I like to call them, are cover directives, either System Verilog or PSL cover directives. So, window layouts. As I said before, we can move windows around. We can rearrange the windows the way we like them. And every once in a while, you'll kind of move a window and it'll get stuck in a corner and you won't like where it is. So you can always go up to this layout reset to put everything back if things get messy. Now, if you create a layout that you like, you've moved windows around, you've got it all set up, you probably want to save that layout so that then it will be available later to come back to as my layout. Saved layouts, you can grab them from that layout main window, or you can grab them from the little layout gadget that ends up on your toolbar. So each kind of phase of simulation has its own default layout. So if I go into Layouts Configure, you'll see when I first start up and I haven't loaded a design and maybe I'm just doing some compiles, I'm kind of in what's called the No Design Loaded layout, and by default we use the No Design layout. When we go into simulation, we use the Simulate layout. If we're doing either code coverage or functional coverage with assertions and things, we go into the coverage layout. And then there's also a data set called verification management for pulling up multiple simulation runs and merging coverage information, etc. That's the verification management. So these, again, are the default layouts, but if I've created my layout, I could come over here to Simulate and say every time I go into Simulate, instead of going into that layout, go into my layout. I would say you probably want to leave this Save Windows Automatically checked, because that way it just saves the layouts as you create them. And then you can also check this box, which is not checked by default, and that says, depending on which working directory I'm in, store the layouts in there. So for one project, you might have one set of layouts. For another project, you'd have a different set. So that's, if you check this box, you would get that. Otherwise, you kind of globally set it for all your projects. All of the menus in ModelSim are context sensitive, or actually this main menu bar, there will be this one column right here. So these will be common, but depending on which window you pick, which we've clicked on and made active, it will change this one column. So for instance, when I'm on the library, I have this library window. If I click on, say, the memory list, that column will change from library to memory, and it will be the context-sensitive things that I want to do with memories. And then again with the wave window, if I click on the wave window, that wave menu will be available, and I'll be able to work with the wave kind of things. Now, if I undock any one window, so I take this wave window and I click the undock icon and pop that off the window, what happens is all of these menu items that were available under the wave become the top level menu available within my wave window. So it's context sensitive. Undocked, you'll get kind of the next level of menu available for working with. So the toolbar. In the main cockpit, we have this toolbar with lots of different things that we can work with. If you right-click in the blank space in that toolbar, you can select what to show in this toolbar. Because sometimes there's things in there that are, maybe I don't care about this compile menu, or I might not care about the simulate or some of the other things. So I can right-click and I can check or uncheck which toolbars to display in this window. You can drag a toolbar off of here. So if you select this little handle, you can drag that toolbar out, and then it becomes a separate floating window within your environment. That can be helpful, I guess, if you want to keep certain things handy. Generally, I keep all the toolbars docked to that toolbar. Now, one of the things I have noticed, and I will say I haven't noticed this in a while, but occasionally you'll see that the toolbar will get all scrambled, and you'll have all this white space that's consuming all your real estate. If you right-click in that space and you say reset, that will stack the toolbar back to a nice, tidy menu, and it should then take effect and stay effect. So I found that I had to do that about 2 years ago, and whatever bug was in the tool has been fixed, and the toolbar, once you do that reset, usually stays pretty nice and compact. So you can drag and drop objects between most windows in the tool. So for instance, if I were to select this signal variable restore and drag that over into the transcript, what I would get is I would get the word describe that signal put in the transcript. So that's great, because now I know the full path name to that signal. I can cut and paste that path name, and I can use that in scripts that I build. We can drag and drop from all kinds of places. The source code window is one slight option, is that you cannot highlight and drag and drop from there, but what you might do is highlight a section of code, right-click, and say add to maybe the wave window or the data flow window or whatever, and that will throw those signals into that window. So every window has a set of keyboard shortcuts. This was actually something that I didn't know about until relatively recently. I knew some of the keyboard shortcuts, but I never knew how to actually get them to turn on. So if you are in any one window, what you hit is the Control key and the slash key. This shows Control plus slash, but it's really just the Control and the slash, and the plus is doing those two things at the same time. So if you do that, Control slash, it brings up this menu that has all of the keyboard shortcuts for, in this case, the data flow window. So I can zoom full with F, I can zoom in with I can zoom out with O. For the wave window, I can scroll up and down with the up and down arrows. I can scroll right and left with the right and left arrows. Zoom, again, full with the F, in with the I, O with the out. You can add a cursor with the A key, etc. When you're done with that keyboard shortcut window, you just hit Control slash again, and it will close that window. So for the source code window, again, there is a set of keyboard shortcuts, and you can see it by hitting Control slash and then Control slash again to get rid of that control shortcut. Strokes. So especially in the wave window and the data flow window, these can be really useful. So that's mouse strokes. So if I have the wave window open, I can zoom full by, let's see, I think it's the middle mouse button, and then drag from the bottom right corner towards the upper left corner. So middle mouse button here will zoom out to the full wave window. The opposite is true for zooming in. I can pick an area that I want to zoom over and start at the top here, middle mouse button, and drag down. And when I let go, that will zoom over that area that I happen to be in. And then zoom out is from the bottom right up, middle mouse button. So again, those are just some of the strokes that you can use. I think if you search in the help menu on strokes, it will bring that up. But those are probably some of the most useful strokes that I just do unconsciously now. But again, a lot of people don't know that that's there. If you don't have a three mouse button, you can just push the right and left simultaneously, and that works like the middle mouse button. I don't know who doesn't have a three button mouse anymore, unless you're a Mac user. So next we'll talk about projects. Projects is, ModelSim can work in one of two modes. You can work in a script mode where you just have the transcript window and you've written do scripts to compile, launch your simulation, etc. That's kind of my preferred option, but we do have a project mode that allows you to let kind of the tool auto-generate all those scripts and things for you. So project mode, you create a new project, file, new project, you give the project a name, you tell it what directory it's going to live in. You probably leave the working directory to work unless you have some reason. Copy settings from the ModelSim INI of the install, and then basically that creates your project. And what that creates is this file called projectname.mpf. So MPF stands for ModelSim project file, and that has a whole bunch of stuff that controls your project. So basically what it does is it takes the ModelSim INI file, which is a bunch of the configuration stuff for ModelSim, copies all that to the top, and then at the bottom it puts in this area all about projects. And it puts in, where all the source files are, what the state of they are. Like, for instance, if it's VHDL, it tells it whether it's VHDL 93 or 2002 or 2008 context, etc. So all of that information is contained within the MPF file. And just as a word of caution, I would not go and edit that project area information. You can really screw up the project and have to start from scratch if you go and edit that file. So once you've created a project, now it's an empty project, and I can either create some new files, or I might want to add existing files. So you can do that either from the project, add to project, or when you first started the project, it will bring up this add to project menu, so you can add existing files, let's say. So I click add existing files. I can go browse through my directories, select a bunch of files, and then I can add them to my project. And when I add them, I can either reference them in their current location, in which case I'm just looking at them, I'm not making a local copy, or you can copy them into the project directory. So that would be, I would want to do that for things that I'm going to change that I don't want anyone else to have those changes. So now I've added a bunch of files to my project directory, and so I see this list of all the files in my project. It tells me what type of files they are. It tells me what their compile status is. It tells me when they were last modified, and a compile order. So you can sort the project by clicking on any one of these columns. So you can sort it alphabetically, you can sort it by compile order, etc. This question mark in status means that I've brought this file in, but I have not compiled it yet. So compiling the source code. There is this toolbar this tool in the toolbar that is the compile tool. So the first thing here is compile a selected file, compile all files in the project. This is run a simulation, and this is break a running simulation. So that's this little compile toolbar. And then once I've compiled, I will get a status. If the file compiled successfully, I get a check mark. If the compile failed, I get this little X. I can click on any, or I can look at the transcript and see, what was happened, and I see that the FIFO cell.vhdl failed. So I can either click on that in the transcript, or I think I can right-click up here and say show status. So here I've double-clicked on the compile, and that brings up the transcript from that compile, which tells me, that I had a problem at line 21 of my code. So if I click on that, that'll open up the source code, take me to line 21, and I can see what happened was I misspelled weight here, and so that became a syntax error, and got pointed out. So I fixed that and recompile, and everything should be good. Now, VHDL. VHDL has something called compile order. You need to know the order of the files in order to compile them. And that is because what the LRM says is that I cannot compile an architecture that instantiates an entity, that instantiates a component before I've compiled the entity for that component. So that means I need to compile basically bottom up with VHDL. So I can either, if I know that, I can come in here to the compile order and I can select these things and drag them around, or I can actually select them and use the up and down button to order things, or I can hit this auto generate button and it will analyze all the source code and try to figure out all the dependencies and order the code automatically so that I don't have to do that. And that works 99% of the time. Once you've hit that auto generate and generated the compile order, if you go back to your project, you'll see the compile order, and that's like a good column. You sort by compile order, and so you kind of see either top down or bottom up what order your files are in. So to start a simulation, I hit the Start Simulation button. That'll pop up this Start Simulation. I go into my working directory, select the top level of my test bench, and so I've expanded work, selected the top level of my test bench, and you hit OK, and that will start a simulation. Now, that's one option. Another is what I can do is I can add to my project a simulation configuration. So here I've gone project, add to project simulation configuration. I give that configuration a name. In this case, I'm calling it smoke test. I pick that top level test bench. Maybe I have to go into my VHD, my menus here, VHDL, some things about, libraries. If you have Verilog code, you might need to go in and say, what libraries do I need to search? So you might need to go in and put a few, configure a few things for different areas, but then I save that configuration, and what turns up now in my project view is I see this ModelSim configuration called smoke test, and when I double click that will go through this task of selecting the delta and starting my simulation. So that's how I get projects running in ModelSim. If I have a project, when I close the tool, the next time I open the tool, it should open the last project that I was running. If you wish to change projects, you can then say File Open, you can say Project, find that testdelta.mpf, select that, and that will open the project, change the directory, get you ready to run that project. As I said before, projects remain open until I close them explicitly. So every time I open the tool, I will open it up and be using the last project that I had been working on. So if you want to close it, you have to explicitly say File, Close Project. A minor thing that you should be aware of is that these project MPF location gets stored in the Windows registry, and really the important thing is close a project before you delete an MPF file, because if you don't, you could confuse the Windows registry. So just something to be aware of. So what's the alternative to running in project mode? The alternative to running in project mode is to create a simulation do file. So you create a file that has all the steps that you want to do. So now maybe I'm not in simulation mode, and if I don't know how to do this from scratch, I could just be not in simulation mode, change directory to the one I want to go into, and then I can go command history, and I'm saying store my command history into this thing called mysimulation.do. And then I'll go into the compile, and I'll say compile a few things of code. I'll go into simulate, and I'll simulate. I'll add some things to the wave window. And then I quit the tool, and then that mysimulation.do file gets saved into this script file. So what you can see here is now this script takes the place of that project file. So it says change directory into my working directory, create a working library, compile some set of source code from this list file. So it's and then it's saying launch the simulation on my FIFO test bench with these arguments, add some different waves to the wave window, and then run my simulation. So that then what I would do to execute that is I would go tools, tickle, execute macro, and select that. Or if that's in the directory that I'm already there, I can just type at the command prompt here, do mysimulation.do, and it will run through all those commands for me. So that's kind of the alternative to doing project mode. And honestly, I feel like I have more control. I like doing things in that way. So the one problem with this goes back to that idea of a VHDL compile order. I need to figure out the VHDL compile order of my project. So here's like a typical VHDL project where I have all of these different pieces. This is the hierarchy of my project. And what the LRM says is that before I can compile this architecture right here, I need to compile these two entities that are instantiated by that architecture. Now, if I had put all of my entities in a file and then architectures in separate files, that would be relatively easy to do. I could just compile all the entities first, compile all the architectures second. But that's not what we do. What we really do is we put our entity architecture pairs in the same file if we're doing VHDL. So that is why now I need to know that I have to compile this entity S1 before I compile this entity architecture pair, because S1 needs to be compiled before the architecture RTL of B1. So that's what dictates compile order. So ModelSim for scripting gives us a few tools to help us do that. And that's when I compile these entities and architectures, I can use this -skip and this -just flag. And so skip says skip whatever entity, packages, blah, blah, blah. Just says just compile an entity, just compile an architecture, just compile a configuration. So about 75% of the time, when somebody hands me a directory full of VHDL files and they say, I can't get this simulation running, rather than go and look through there and try to figure out what the right order would be, I can just say vcom, skip all the architectures, and compile the code. So what it does is it goes into each file and it says, okay, there's entity S1, compile that. Oops, that's an architecture, skip that part of it. Here's entity B1, compile that. That's an architecture, skip that part of it. So as long as there's not a lot of packages involved, this will compile about 75% of the code that I get. And I might need to say, okay, the packages I need to compile separately before I do this. If I can't figure it out that way, this script will compile just about any bit of code you throw at it. So here what I've done is I've created a library called work. I said vlog all the Verilog code, and then I vcom just the packages, just the package bodies, just the entities, just the architectures, and just the configurations. And that will compile most sets of random code that somebody kind of throws at me. The next section we'll talk about is managing simulation messages. ModelSim can present you simulation messages in a couple of different ways. The first way, and the one almost everyone knows, is through the transcript window. So that is, the transcript gets created, simulation messages are put in the transcript window in the order at the time they are received, and all of those messages are in the transcript, and I either have to look through that transcript or maybe use some kind of either Perl script to filter that transcript a little. So we also give you this thing called the message viewer, and the message viewer allows us to pull out messages of certain types and categorize those and put them into categories, and it will have the time that they occurred, but it helps me to bring some order to a really noisy transcript. So if there's a ton of messages that I don't care about, I can close that note category and just look at the error categories. So how do you enable that? There's two different switches that you can throw. And so the -display mode, you can say put the messages in the transcript, in the WLF file, or in both places. And that handles the Verilog $display, fdisplay, strobe, monitor, write. And then all of the other ones control assertions, so system Verilog assertions and the VHDL assert statement are controlled by message mode. So as VHDL, you need to use either assert or report to get those messages into the message viewer. And then what happens is all of the messages of particular categories get thrown in. You can write filters to put messages into different category areas. If you right-click on a message, you can right-click and say view the source of that message. You can go to that message in the wave window. It will put a cursor right at the point that that message was put out, and you'll see there are these little ticks up here in the message bar that say that a message happened. So if you're looking at the wave window, you can say, oh, right here a message happened. And you look down, you see, oh, it happened on this signal. And if you put your cursor there, it will pop up the message that was put out. So it really is like a nice way to bring that message information into the wave window, allow you to interact with it, categorize it, and help you to filter all of that messaging. So now let's talk about source level debugging. The source window is obviously the spot where ModelSim displays your source code. The window will show all the line numbers down here, and you'll see the line numbers that are highlighted in red are executable line numbers. If a line is executable, you can click right next to it, and that creates a breakpoint. So as the simulation runs, if it hits that breakpoint, it will stop, and then you can use the single step to step through. So the arrow is indicating where we are currently in the code. The code is syntax highlighted, so keywords are highlighted in red. Line numbers are in red, breakpoints we talked about. If I put my cursor on a signal, it will pop up the value of that signal based on the time marker that is right here. So now I'm at the time marker now. We can use this as an editor. By default, it is in read-only mode, and quite honestly, I'll use that as an editor if I want to make a quick change, but if I'm going to be writing massive amounts of code, I'm probably not using the source code window as my editor, but if I come out of default mode, I can make some quick changes. Breakpoints can be placed on executable lines, so basically lines that are red. I can place a breakpoint. If I just click, I can set a breakpoint. I can right-click and say set a breakpoint at a certain time. I can disable breakpoints. I can remove breakpoints. I can edit breakpoints. So what does that mean to edit a breakpoint? So now I've right-clicked and I said I'm going to modify a breakpoint. So I've gone to this breakpoint at line 20. I can give that breakpoint a label. So instead of just showing line of code in certain file, I can give it a label. More importantly, I think I can give it a breakpoint condition. So, for instance, sometimes I will be running code, and at the beginning of the simulation while I'm in reset, I'll hit that breakpoint 6 or 8 or 10 times, and I just have to keep hitting run continue. And if that takes a little while, another option is that I could say, don't actually break on that breakpoint until my CR3 strobe is a 1 and my P4 strobe is a 0. And then when that breakpoint is hit, I can actually run a do file. I can run a tickle script. I can take actions based on hitting a breakpoint. So that's kind of an interesting thing there. Once I've hit a breakpoint, now I might want to single step through my code. So this is my step menu, and it has a couple of different types of steps. One step will step along and just follow the execution of the code regardless of the thread. And my steps are step into, which is step along. If I hit a function call, step into that function, step through there, come back out. Another one is called step over, and that says I'm stepping along, but if I hit a function call, go ahead and run all the code in that function and then step to the next line. So it is don't follow down into a sub-function call, run the function, and then step to the next line in the file I'm in. And then there's step out of that just says step out of this code. If I'm in a function call, say step up and come out of there and then stop. So that's the normal flow. The other one is the thread-aware flow. There are multiple threads running in any simulation at the same time. The thread-aware flow says stay in the current execution thread and don't step over into another module, another thread of execution. So you can turn on source code annotation, and what that will do is it will annotate the value of each signal right underneath it. And so, for instance, right here, I'm at a time where the clock is transitioning from 0 to 1. So source code annotation will annotate all the values in my code. You can change the time, so you can jump to a particular time. You can tie that time to the cursor, so if you move the cursor in the wave window, it will go to that time. So the next section we'll talk about is viewing and working with waveforms. So the first thing we need to talk about is logging signals so that they get into the waveform database. So I'm sure we've all had situations where we've been running a simulation. We go to put a signal in the wave window, and that signal has no data. It's blank. And I have to stop the simulation, restart, and rerun to that point to get information. And the reason that that signal is blank is that it hasn't been logged, it's not recording, and all of that information gets stored in this file called the vsim.wlf by default. So every time I put a signal in the wave window, so when I add a signal, that tells the simulator to now start logging the data for that signal into the WLF file. But there is a way to say add to the log certain signals, and that will add it to the database. It won't necessarily be in the wave window, so you can be recording thousands of signals, but only have 20 or so in the wave window. And so, one option we're showing here is I'm just saying add to the log every signal in my design. So that is good for a small simulation. If you have a very large simulation, you are going to be creating very big WLF databases. So in that sense, a better idea, say we're debugging the preprocessor section of my design. So you could select that module here in the Sim tab, and you could say add to the log all items in this region and below. And that would add everything in the preprocessor and below to the log window. So any signals you put from the preprocessor will be there, but you're not going to have the 500,000 other signals in my design in your log file. So that's just saying, use that log to your advantage. Log the things that are important to you. Don't necessarily log everything. So adding signals to the wave window can be done in a bunch of different ways. You can select things in the Sim tab, and you could just actually drag that module over, and that will add every signal into the log window. If you select that, that'll bring up all the signals in that module up in your objects pane. You can pick and choose from there. You can highlight a block of code and right-click and say add that to the wave window. So there's lots of different ways to add signals to the wave window or to the log. Once you have a bunch of signals in the wave window, you might want to do things like create dividers. So dividers are just going to be a little marker in your wave window. So I'm going to go right here. I'm going to say add a new divider, call it memory. And now, I've got just a little reminder that says all the signals below here are from the memory. So that's the kind of the original way we used to do it. Now we have things called signal groups. And I think this is a much better way to do it, because now what I can do is I can select a whole bunch of signals. I can right group. I can say create a group called memory. And then what that does is it creates this collapsible group called memory. So I can click on that minus sign, and that'll roll all those up. And so what that allows me to do is now create a bunch of signal groups so that I can kind of have a whole bunch of signals in the wave window, but only open up the groups that I'm currently interested in. I can move those groups around in the wave window, etc. So you can expand and collapse. The default radix, so I can go into simulation runtime options and I can pick the default radix for signals. So personally, I like to see most of my multi-dimensional signals as hexadecimal. So I would pick hexadecimal as my default radix. And then every signal would be hexadecimal by default. Now, once I have a particular signal, I can go in and I can right-click on this FS address and I can set a global signal radix just for that signal. So in this case, I'm going to call it unsigned. And what that will do is it will show in the wave window as unsigned. It will show in the objects tab as unsigned. It will show in any other place as unsigned. That sets the global radix for that signal, but I can also override just the thing in the wave window to maybe show in the wave window, show it as hexadecimal or something. Or in this case, I hit unsigned again. My global radix was binary. I changed it to unsigned. Everywhere else in the GUI will remain binary in this case. Just this signal in the wave window will be overridden to show unsigned. Wave cursors, you can add cursors with the add, you can remove cursors. If you select a particular signal, so here I've selected the clock, and I can use these buttons to say go to the next transition, whether it's rising or falling. The highlighted cursor will be bold. All of the annotations over here will be tied to whatever my active highlighted cursor is. You can lock and unlock, and you can edit some properties, etc. with these little toolbars over here. So the first one, I've selected a cursor. I've said cursor properties. I can actually give that cursor a name. I can tell it to go to a particular time. I can also click lock, and in which case it will show up as locked and show up red. That means it can't be moved. I can remove a lock just by clicking on the little lock button, so I can lock and unlock right here. I can link cursors together. So now I've linked my two cursors in my design together. So if I move this cursor, it will also move the guy that's locked between it. So maybe what I've done is I've said, here's some event that I'm interested in. This is a pulse width that I'm interested in. So let's move over to here and make sure that that pulse width is the same here as it was here. So that's what you do by locking cursors together. So originally I was showing the cursor and it shows the time between cursors. If I bring up the wave preferences, I can select show frequency between the cursors. So that'll now show the delta in frequency. Here I have the absolute time that I'm at. And so the grid is shown in time. What I can do is I can configure that grid. I can say my clock period is 122 nanoseconds and the first rising edge is at 61 nanoseconds. So let's set that up as my grid configuration and display as a cycle count instead of as an absolute time. And when I do that, I'll now see this is on the 325th rising edge of the clock. And if I put cursors in there, it would show me clock counts between those cursors rather than time between those cursors. So the display properties, again, I've brought that displays properties up with this menu right here. And I can say how many elements to show in the path. So if I set it to 0, that's going to show the full path. But sometimes that full path, if I have a lot of hierarchy, gets really long and it's hard to read. So I could click on 1, and that will just show the signal name. If I say 2, it would show the signal name and the instance name just above it. If I show 3, etc., etc. I can quickly toggle back and forth between full path and single path with this button right here. That will toggle me back and forth between the full path and the just the name. Let's see. If you can kind of see, there's little yellow marks, and that denotes where the cursors are currently. And this is showing, this is the time that I'm currently zoomed in on. So if I moved this over and centered it around this, I would be centering the zoom window around that particular cursor. And then right here, I've selected a signal name, and you can see that's the selected signal name, and actually that's down in my list, and I'm only showing the top, 10 or 12 signals, and that's up here. So I could drag this down and bring it down to the selected signal name. So yeah, here I drug that view over, so I centered it on that cursor. You now see that yellow line is in the middle of my zoom, and that cursor is in the middle of my zoom range. And then the selected signal is right here, and you can see that's where my zoom line is. So once I've put a bunch of signals in the wave window, I've created signal groups, I've got all the waves, I don't want to have to do that every time. Hopefully you know that you can go File, Save Format, and that creates by default this file name wave.do. You can name that whatever you want, but the default name is wave.do. So when I save that, it creates this this do file that's going to add all of everything that was in my wave window back in. So all of the signals that I had will be put in, the cursors. So here's all the signals. You can see that if I've overridden radixes, it will put that in. If I've created signal groups, it will put in the signal groups. So I had an input and an output signal group. Any cursors that I had in the window when I did that save, and then a few other configuration things. And then finally the zoom range that I happen to be in when I save that. This is another property of the wave window that helps me debug zero-time events in a simulator. So in VHDL, they have formalized this into something they call delta delays. It is zero time step delays that help us model concurrent behavior on a computer which is by its nature sequential in nature. So things are happening one at a time in the computer, but we are modeling concurrent behavior. So here is a bit of source code. I was trying to model a register here. So I have a clock, I have a data in, data out, but I've been kind of sloppy in my coding. And somewhere in my code said clock 1 equal clock, somewhere else I said clock 2 equal clock 1. And I'm using clock for the first register, and I'm using clock 2 for the second register here. So if I run this simulation, what will happen is it will look like in a single clock, data goes from data in all the way to data out and skips through D1. So here's the wave window, zoomed in really close. I see my clock edges. On the clock edge, the thing on data in goes to D1, and then immediately goes to D2, and immediately goes to D out. So it looks like it's skipping forward in that register. So to debug that, we used to have to look at this thing called the list window, which showed the events, it showed the different clocks. It was really hard to read. I'm not going to go through it because now we can zoom in to that delta mode. So if I put my cursor here and I click on this thing that says, okay, let's go into delta mode and let's zoom around the active cursor. So I expand, and what that shows me is here's clock tick 550, here's clock tick 551, and we saw that, everything happened all at once up here. Well, down here I see the delta events. So I see clock going to clock 1, going to clock 2. And then here is the original data. And so one tick, one delta cycle after clock goes high, then data in goes the D1 output of my flip-flop. And then, oh, look, here is the clock 2 that I'm using for my second shift register. And here is D1 going to D2. So this is a shift register. It's just the problem is the clocks have delta cycle skew, and they've caught that transition because of that delta cycle skew. So it helps point out when weird things are happening in delta time. Now this is delta time, and you see there still are 2 events that are going on at the same time. So there is actually a level even below that called simulator step time. And in simulator step time, these events are actually separated. So I can zoom further into event time, and then in event time, I am guaranteed that no 2 signals are transitioning at the same time. This is the sequential stepping that's going on in the simulator. So if you can't debug in delta time, you can push even further down to simulator step time. So it's just ways to chase down really race conditions in your design. The wave window allows you to go edit signal search, and you can search for transitions on a signal. If you have a bus, you can search for a particular value, or you can search for an expression. So in this case, there is this thing called the expression builder. So it will bring up all the signals in your design. It will help you build this expression, but this is just saying search for a time when CPU wait equal 1 and CPU read equals 0. Search from the end of time, or from the start of time until the end of time, and find the first time that that happens. In this case, you hit search. That will find when that is the case. It will center the cursor on that time, and it helps you to track down bugs based on this search pattern. You can display signals in analog format, so by default, it is going to be a step function. So you give a signal, you say you want it to be formatted as an analog, and so the signal sign X, you can put clipping values in. If you want to, instead of showing it as, discrete times, you can interpolate into analog. So here I've said analog interpolated, and that just gives me a smoother signal. So you can do some interpolation of analog signals, so displays things that make sense to look at them as analog. You can do that. So the next section is the graphical data flow. In this section, we'll talk about how to trace events that I see in the wave window and try to get them back to source code. So this is showing that I can add signals from the sim view, from the objects view, or from the wave window to the data flow window. Generally, I'll tell you, it's usually when I'm looking at the wave window and I see some unexpected behavior on a signal that I say, well, where did that signal come from? So I double click on that signal, and it brings up this data flow tracing view. So it traces back to the initial block where that signal was generated. And then from there, I can trace backwards from where the clock in that initial block came through. These little plus signs are hierarchical boundaries. Here is the clock generation process that was on line 59 of some block of code. It will annotate the value of all these different signals on these ports of this as long as you're logging them. And if you have Verilog primitives, so if you use OR, and whatever, those Verilog primitives will actually show up as gates. And then you can trace back. You can double click on any one of these lines and trace back to where that particular signal came from. You can open up an attached wave viewer. So if I select this block, I could click the wave viewer and it would put all of these signals into that wave viewer. So let's see. This was the chase back an X. So there is a special function that if you have an unknown, that it will help you trace back where unknowns came from. This is open to all drivers, open to all readers. Oh, I can turn on hierarchy. So I could, if I turn on the hierarchy, then instead of the little plus sign, it will just put hierarchical boundaries. Let's look at the attached wave viewer. So in this case, I select this assign statement. And when I select that assign statement and I turn on the attached wave viewer, it'll automatically show me the output and the input, the strobe R input and the strobe output of this assign statement. So if I clicked on this initial block, it would put all these signals into this wave window. So it really just gives me a quick way to go to a wave window, help debug. If I double click on that, it'll open the source code. I can debug between the source code and the wave window. Realize I have to trace further back. So this attached wave window can be useful in that manner. So wherever I place the current cursor, that will be what values are being annotated on this line. And then a special feature is the finding root causes of X's. So if I see this signal right here that's an X, what I can do is double click on that, open up the trace window. It shows me that it's this buffer, and I see that the reason the output is an X is because the select on that buffer is an X. So I could double click on that and trace back a little further, and I could go do that manually. But if I use this chase X function, it will try to chase that X back as far as it has to until it finally comes across a place where there's a gate that has an X output, but it didn't have an X at the input. It had a 0 and a high Z, which is kind of interesting. So if I now double click on that gate, it brings up the NOR gate that was in there, the Verilog primitive NOR gate. And then I kind of look and I say, well, what's the value of test 2? I hold the signal there, it's high Z, so I can use the search window now and find that I never initialized test Z to anything, and it's uninitialized, and that's why I have this issue. So, coming up on the end of the webinar here, the last thing we'll talk about is working with memories. So, any two-dimensional array that I have in my code. So if I have declared anything as a two-dimensional array, and you can set a limit, a size that says if it's at least X number of bits, then display it as a memory. So in this, there is this thing called the memory list, and it will look through your code and it will find any two-dimensional arrays. It will display all the two-dimensional arrays in the memory list. So then I say, okay, this right here, this 128 deep by 8-bit wide thing, let's show that as a memory. So if I double click on that, it brings up the memory view of this signal vectors. So down here is the address, and over here is the data. And so the address is currently shown in hexadecimal, the data is shown symbolic or binary. I can right-click and change the properties on that. So if I change the properties and say, let's show the address as decimal, let's show the data as hexadecimal, and let's show 4 words per line. I say OK, and what comes out now is the decimal address, 4 per line, and data shown in hexadecimal. So good way to view two-dimensional arrays, say. If I want to say, try to correlate between, maybe what's happening up here in this range with someplace much deeper in the memory, what I can do is I can split the memory into two different scroll ranges. So now I have two independent windows, and I can scroll each one of those, and I can maybe look for some correlations between these ranges up here, and then somewhere deeper down I can look at that. So splitting gives me two independent scroll regions. I can go in and poke any memory location. So I can just select that memory location, and I can write whatever I want to into that particular location. So that's good for doing individual addresses. If I want to change the entire contents of the memory, I can right-click and say Change, and that brings up this menu that allows me to say, okay, over the entire address range, let's put in a particular value, put in an incrementing value, a random value. With this skip, I can say, okay, let's skip every other word starting at 0, put in 55, then starting at 1, skipping every word, put in AA, so I can put in a checkerboard pattern. Lots of different ways that I can change the entire contents of the memory with this change window. I can export the pattern that's in the memory, so I can right-click and say Export the pattern, and that allows me to save the contents in either a Verilog hex, Verilog binary, or our proprietary MTI format. I can save the entire range or just a specific range. I can include the addresses so that if I read it back, it would read back particular addresses. So lots of different things. Give a name, say OK. And then similarly, I can use the import pattern in the same way. If I say data, I'm really doing the same thing as the change memory, where I'm doing particular ranges. If I say file, then I can read back from that file that I wrote out earlier in whatever format. And if I do a combination of both, especially if I had an address that was included in that file, I can fill in the address and then overwrite that with all the addresses that are in that file name. So let's see. I can compare the contents of two different memories. So for instance here, I'm saying, let's look at my results memory, and let's compare that to this file that I saved away earlier. And, maybe the correct answer is that I compare those two things. It uses tkdiff, and it says those two files are identical. I say, hey, my simulation passed. If they're different, it will highlight the differences between my gold standard and my actual results. So that's pretty much everything. The summary is that there's a lot of great tools in ModelSim. Most people don't know everything that's there. And what we hope is that what we showed you today is going to trigger some ideas on how you can be more effective in your debug tasks using some of the built-in tools in the GUI. So from here, we'll head over to the chat window and take any questions